Alright, welcome back guys. So today we'll be seeing how to use an LDR with an Arduino. So the basic idea of an LDR is that it is a resistor that can detect the intensity of the light around it. So what it does is basically when the intensity of the light changes around the LDR, the resistance of the LDR will change accordingly. Now you could use this with an Arduino or a similar device to take the data from the take the data of the light intensity and use it for purposes like maybe a light switch that can where that will switch on the light when it is dark and it will switch off the light when it is bright. So it can do such things. So let's check out what an LDR is. Basically it's a light dependent resistor. It is also called a photoresistor. Now we should also see how the intensity of the light affects the resistance of the LDR. So in order to do that, there's basically a graph. So I'm going to just show you this plot. Okay, so this is the basic curve of an LDR. So as you can see, when the illumination, that is the brightness of the light around it, when it increases, the resistance of the LDR decreases. So when it is dark, the LDR has a very high resistance, and when it is dim, when it is very bright, the LDR has a very low resistance. So now microcontrollers like Arduino and all those, they cannot read resistance as is. Like they do not have the capability to read resistance values. So what we need to do is we need to convert this resistance into voltage, right? So it has an ADC, analog to digital converter, which using which it can convert the voltage into digital signals, but it cannot read the resistance. So let's convert it into the voltage. Okay, so in order to do that, we can use this very simple circuit called a voltage divider. Okay, so what it does is basically we take a 10 kilo ohm resistor and connect it in series with the LDR. So by doing this, what happens is at the junction point of the two resistors, that is the LDR and the fixed resistor, we get a variable voltage that will denote the intensity of the light around it. So let's see how that works. Okay, so in order to know that we need two formulas that we most probably learned in high school. So this would be so one of them is Ohm's law. So Ohm's law says that voltage equal to current times resistance. So this is a very common equation in electronics. And the other we need is the formula for equivalent resistance in series. So this is basically the sum of all the resistance that you get. In this case, the equivalent resistance for this entire circuit is Ra plus RL. So Ra is the known resistor and RL is the LDR. Okay, all right. So now since we know this, let's apply this Ohm's law in this circuit here, and let's see what we get. All right, so this is what we get. All right, so when I multiply yeah, so the voltage from the between ground and 5 volts, it is 5 volts here. Okay, so voltage between ground and 5 volts is current times the equivalent resistance of this entire circuit. So it is I times Ra plus RL. Now since Ra is known, it is 10,000, so it is a 10 kilo ohm resistor, so it is 10,000 ohms, and 5 equal to I into 10,000 plus RL. So this forms our equation 1. All right, so now let's try to check out the voltage at the V out point. Okay, so I want to check the voltage between ground and V out. Now how do I do it? So I could simply apply Ohm's law on only this part of the circuit, right? So the V out voltage between ground and V out, that is V out, is equal to I times, now since this is a series connection, the current that is passing through the resistors, both of the resistors is same, so it is I times Ra. So since Ra is known, it is 10,000. All right, so now in this two equation, this would be equation 1 and this would be equation 2. In this two equation, the current is the only unknown factor in here that we don't need. Actually, we have no use for monitoring the current in here. So let's get rid of the current by dividing the two equations. Okay, so let's do that. Okay, I'm going to hide that part since we already seen that. Okay, so if we divide the two equations, 5, this is the equation 1 and this is the equation 2. 5 equal to 10,000 plus RL and V out equal to I into RA. Okay, so anyway, so if we rearrange the equation a bit, and now the I part will get cancelled out and we lost the I here, and if we rearrange the equation to get V out, we can see that V out equal to 5 times RA by 1000 plus RL. Now all of the values here is constant. Now RA is actually just a minute, so RA is actually 10,000, so I could just paste 10,000 here. Okay, so here the only factor that is variable is RL. So if RL increases, the voltage will if the resistance increases, the voltage will also decrease, and if the resistance increases, if the resistance decrease, the voltage of V out will increase. So that gives us a graph something like this. All right, so here you can see that when the resistance RL is, when the resistance is low, the voltage would be high, and when the resistance is high, the voltage would be low. All right, so this gives us a very basic idea of what the LDR is going to do and how the voltage that we will be getting in the circuit will affect it. Okay, so now what I'm going to do is I'm going to create a voltage divider with an LDR, and I'm going to connect it with my Arduino and program it and see the data that we are getting. All right, so for now that is the theory part is ending here, and actually we don't even need the equation, right? So while programming it, we don't really need the equation, we won't be using it much. We just need to see the relation between the RL and the V out. All right, so now let's get to programming it and checking out the circuit. So okay, so as you can see here, I have made the circuit already. So what I have done is I have taken a LDR. So I have connected 2 wires to the LDR. All right, so this is the LDR, right? I have connected 2 wires to it. I have connected a 10 kilo ohm resistor in series with the LDR, and I have connected one end of it to ground. So the 10 kilo ohm resistor is going to one of the ends of the 10 kilo ohm resistor is going to ground, and the other end of the of the LDR is going to 5 volts, and the junction is being connected to pin number A0, analog 0 of the Arduino Nano here. And I have also connected an LDD to pin D3, digital 3, so that is for later use, so we'll check that out later. All right, so right now let's start programming and see what kind of data we will be getting. Okay, just a minute. Okay, so I have opened up Arduino IDE and let's start programming now. All right, so what I'm going to do is I'm going to capture the data from the LDR and I'm going to print it on the serial monitor just to see what kind of raw data I'm getting. Okay, so I'm going to start the serial communication. Okay, I'm going to use a baud rate of 9600. So this is basically the speed at which the Arduino is communicating with the computer. All right, okay, so now what I'm going to do is I'm going to just print the value that is being the voltage at analog 0, at point analog 0. Okay, now there are a few more things that we need to see. Since this is the first video I'm doing about Arduino programming, the structure of the program is basically that we have 2 functions, that is setup and loop. Now setup is like a constructor similar in Java and all those object-oriented programming. This is the part that will be called once when the program gets initialized, and we use this to initialize all the pins and all those pins and communication and all those things. Now, the void loop is a function that gets called. It's goes through a loop. So this is basically an infinite loop. This function is basically an infinite loop where which calls it an infinite loop. So when I run this program, initially the serial dot begin will be executed, so the serial communication will be initialized, and then when we go into the loop, it will continuously print the analog read A0. So analog read A0 will return the value at voltage at A0 in so since Arduino has a Arduino Uno and Nano both have a 10-bit ADC, so it has a 10-bit ADC. So what does this mean? It means that the analog to digital converter that is has a resolution of 10 bits. So the 0 volts would be represented by the digital value 0, and 5 volts would be represented by the value 2 to the power 10, that is 102 2 to the power 10 minus 1. So that is 1023. Okay, 1023. All right, so the value that analog 0 will return will be between 0 and 1023. Okay, so now let's connect the programmer. Okay, let's connect the Arduino, and I have selected the right COM port, and I have selected the right board. It's Nano, and let's upload it. What just happened? Okay, it's uploading. Alright, so the uploading has been done. So now let's check out the serial monitor. So I'm going to click on tools, and then I'm going to select serial monitor. Alright, so here you can see I'm getting a value of around 450 something, right? So I have the LDR here. So when I'm bringing it closer to the camera, the flash is on. So when I bring it closer to the camera, the intensity of the light is increasing, so the value of the LDR is also increasing, right? Also, so when I take it away, the value is also decreasing. Like it's 500 right now, and when I'm bringing it closer to the camera, it's getting around 800 or something like that. So watch what happens when I just cover the LDR with my finger. Okay, I'm going to cover it completely. So see the value drop. So right now it's 100 something. All right, so basically we got a system that can detect the intensity of the light, okay, around it. So now let's try to make a let's try to write a program that can switch on this LED, the red one that is connected to the digital pin 3 to light up when it is dark. Okay, so initially we need to switch on the we need to configure the pin 3 as an output pin. Okay, so in order to do that, I need to write pin mode. So there's a function called pin mode using which you can configure the mode of operation. So is it an input pin or an output pin? So it would be an output pin since LED is an output device. So I'm going to click on write output. Okay, and also I need to specify which pin I'm talking about. So pin number 3 should be specified output. So pin number 3 comma output. All right, so now I don't really need. Okay, now what I'm going to do is I don't need to print the data. Okay, let's let this be for now. Okay, now let's create a variable, let's say intensity. Okay, now the intensity will be analog read A0. Okay, so now this variable holds the intensity at some particular time point. Okay, at whatever time point it is. So it basically holds the intensity at right now. Okay, so now if the intensity is less than, let's say 300, then let me switch on the LED. Okay, so in order to switch an LED on or off, we need to use the function digital write. So digital write 3 comma high, so this will switch on the LED. So digital write, so this is the pin number that I'm using, so the LED is connected to pin number 3, as you can see. So as you can see here, the LED is connected to pin number 3 of the Arduino. Okay, and so I have configured it to be high, and if not, I need to kind of make it low. Okay, so if it is if the intensity of light is brighter, then we don't need the light to show up. All right, so that is done. So let's upload this program and see what happens right now. Okay, so let me just switch on the serial monitor so that we can see what we are getting. So right now the value is around 500 something, so let me just cover it. Okay, so now as you can see, as soon as I covered it, the LED has lit up right now. So I'm going to leave it and see the LDR it is bright enough right now and the LED is off. So I'm going to cover it with my finger, and as you can see, the LED should be light. It has lit up, so it was a bit loose, that's why it did not light up earlier. Okay, so you can see, as when I'm covering the LDR, the LED is lighting and else it's not. So let's run down this program once more so that you can see what's going on properly. All right, so here as you can see, I have taken the intensity value of the intensity of the LDR into this variable that is called intensity, and if the intensity of the light is less than 300, now 300 is a randomly selected threshold point. Now you could configure it to be let's say anything, and you can make it 600, 500 depending on the intensity at which you want the LED to be switched on. All right, so if the LED intensity is less than 300, I am going to switch on the light that is connected to pin 3, else I'm going to switch it off. All right, so that's it for today. I hope you are having a good time. Bye.